Hello and welcome to Microsoft Build 2020. I am Sasha Rosenbaum and this is a session on DevSecOps on Azure, which I'm presenting in collaboration with my friend Dean Bryan from Microsoft. I will let Dean introduce himself later on. As for me, I spent most of my career in application development and then did some DevOps, worked in cloud architecture and product management. I spent a few years at Microsoft and recently came over to GitHub. You can find me on GitHub and on Twitter by the username DivineOps. Please feel free to reach out. So, what is the topic of today and why is this important? Well, we know that security is a big unsolved problem in software development today. And we also know that the more code we write, the more security threats we actually introduce. Another thing that we know is that 53% of all breaches are caused by weaknesses in application code. And actually the majority of the rest is caused by configuration issues. So really most issues are not coming from phishing attacks or so on. They are coming from weaknesses in applications. So the other thing that is an important piece of data is that the faster we remediate vulnerabilities, the better for us. It could cost us very little amount of money if we discover the vulnerability during the development, but it can actually cost the organization millions of dollars if it makes it all the way to production and if we actually get breached. So we want to shift our security left as much as possible earlier into the development lifecycle. But how do we do that? Well, a lot of times we used to think that the security is only the problem of security researchers. But we cannot really make this claim anymore because we know that there's millions of professional software developers in this industry and very little number of security researchers. So really, security should be top of mind for every developer who's writing software. So how can we help developers solve this problem? Well, at GitHub, we're helping you secure your complete application development lifecycle. So we look into securing the software supply chain, and then securing your code, and then of course base it all on Enterprise Foundation platform. So before anything else, let's just spend a minute on the Enterprise Foundation platform. Of course, you're familiar with the fact that in addition to GitHub.com, we also have GitHub Enterprise Cloud and GitHub Enterprise Server, which you can host on-prem. You can also bring your Azure AD identities with you into GitHub Enterprise, so you can use the same identity across your entire organization. And if you wanted to, you can also leverage GitHub identity to log in into Azure Portal. So really, you can utilize the same identities that you used to already across all products. And then you can also leverage all of the advanced security features that you used to from Microsoft products. So you can use role-based access control with GitHub, and you can configure two-factor authentication for your organization, for your repositories, and so on. You can configure GitHub Connect, which connects your GitHub Enterprise server on-prem with your GitHub Enterprise Cloud. And you can also have audit logs for the actions taken in your organization. With that, I'm going to transition to talking about software supply chain. So before we get started, I actually have a question for you. So raise your hand if you're using open source in your enterprise. Okay, I of course cannot see your hands, but I know the answer to this question already. So we know from software composition analysis that 99% of all organizations on the globe make extensive use of open source. And actually, we also know that most of the code that is shipped in your apps is actually not written by you. Only about 10% of your code is your new code, your business logic. Everything else is coming from the open source packages that you consume. And so this is your software dependency graph. Potentially, you can have hundreds of different dependencies, many of which you might not even be aware of because they're so deep into that dependency tree. And then one of these dependencies could become vulnerable. What do you do about that? One of the examples of this is Equifax breach. In 2017, there was an Apache Struts vulnerability that was identified and published on March 6, and then there was a patch available for that vulnerability. But Equifax did not take advantage of the patch. And then on May 14th estimated, they were breached using that same vulnerability. So they really had 2 months to go and remediate their software, but they did not. And my guess is that they didn't because there was no one actively looking at that dependency, and there was no one actively trying to stay on top of all the exposed vulnerabilities and secure the software. So at GitHub, we actually aim to make it really, really easy for you. And we aim to automate these dependency updates and identifications of vulnerable dependencies to a level where it becomes easy to do, not dependent on how many software security researchers you have in your organization. So let's just quickly view a demo of this. So let me switch my screen. So I have a repository here, and I'm going to go into the security tab, and then I will have a feature here, enable security alerts. So I will click on that, and it will allow me to go into this tab and configure security alerts and dependency graph, and then I will also enable secret scanning, which is another feature we're going to talk about a little bit later. Okay, now once I click this, it will actually run a scan of my repository, but that might take a little while. So I'm going to switch over to a repository where I already had this. So I'm in the security tab, and then I can see that I already have a dependency alert in here. So what does this mean? Okay, so I can see that I have a dependency on package name hook, and that I'm using a vulnerable version of 4.1.1, and that the first remediation was introduced in 4.2.1. So I can update to a non-vulnerable version of this. But more than that, Dependabot actually created a pull request for me, and so I can actually go into this pull request and see that it was automatically suggested that I bump the version to a non-vulnerable version of this dependency. And I can just simply click on merge pull request here, and it will go all the way into my master branch. And so this really, I use the word Dependabot, but this feature really comes from an acquisition that GitHub made last year from a company called Dependabot, but it is now fully integrated with GitHub, so you can use it as part of GitHub features. And it generates, it automatically identifies vulnerabilities, and then it automatically generates PRs, and it will also include a compatibility scores for how many tests have passed, so you know that this is not a breaking change. And then we also can see that the resolve rate and the speed for people using Dependabot is much higher than people who are not. So we actually see that it is working for people, and it makes it a lot easier to identify and fix vulnerabilities. Let's switch over to talking about securing your own code. So this is kind of an exciting feature that a lot of people have asked me about in the past. So we now have secret scanning in private repos. So you may already know that we already had secret scanning for public repositories, and that we identify common secret patterns and then alert you to the fact that we identified potential secrets in your code. And now we actually have a beta of this coming to private repos as well. So let's switch over to demo again. All right, so let's go into this same actually repository where we already have this enabled, and let me introduce a code change. So if you have a keen eye, you might notice that I actually already have some dependencies in there, some secrets. So I'm actually going to go way overboard and introduce another one. Okay, and then I'm going to commit my changes directly into master, because I'm just breaking all the rules today. So I'm just going to give it 1 second, and let's go into security tab again, and we can see that we have detected secrets. So not only it detected the secrets that I already had in this repository, it also just detected the secret that I just came in, and it says correctly that it's an Azure Storage Account key, and it will show me where in my code I'm actually using this, and it will suggest a number of ways to remediate this issue. So I can say that I've already revoked this secret. I can say that it was a false positive, so it was actually not a valid secret. I can say that it's low risk and used for testing. So for instance, if I had simulated a secret pattern, or I can just say ignore, right? And so with this, I can actually remediate my issues here quickly. Now, best practice would be for me not to check in secrets into my code. And for this, you can actually leverage Azure Key Vault. So your application retrieves the secrets at runtime instead of storing them in the code. So let's switch back over to the slides and continue talking about the next feature that I wanted to share with you. So you may know that GitHub acquired the company called SAML last year, and it's now available as CodeQL. And CodeQL really does static code analysis. So what do we know about static code analysis in existence? Well, we know that it's still just an aspiration, because if you look at data from Veracode, you can see that the majority of applications are getting scanned maybe once or twice a year. Then only 5% are getting scanned on a weekly basis, and then less than 1% are getting scanned daily. And that's just of applications actually using code analysis. We know that there's a lot of issues with static code analysis today, such as it is complex, it is difficult to configure, it's difficult to consume the reports, and it generates a lot of false positives. But we think that at GitHub, we can actually help solve these problems today. We aim to make the code scanning part of your pull request. So once you introduce code scanning into your repo, it actually scans automatically on pull request, and then on every code commit after the pull request, and it can actually scan the master branch periodically just in case some new vulnerabilities were identified. So basically, it's just like an automated code reviewer which reviews your code before it goes into the master branch. So let's just demo that as well. Okay, so we have a repo right here where CodeQL has not been configured. So let's go into Security tab and click on Code Scan Alerts, and we will see that we can configure CodeQL or a couple of partners that we have in here, and we actually are working on adding more partners as we speak. But right now, I'm just going to go into here and do setup workflow. You will notice that it auto-generate a GitHub action, which will run on GitHub hosted runners. So actually, you don't need to configure a server. You don't need to set anything up. The only thing you need to do is just to do this automated setup and then do start commit. And then I'm going to commit it directly into master just because it's a demo. Right? So if you needed to configure custom steps in here, then you could, but you can also leverage just the auto-generated action and it will run for you. Now, this will take a few minutes to run, so let's just go into a repository that already has CodeQL configured. And let's add a new pull request. So I'm going to use the same code, and I'm going to add some code lines to it. So I'm on a roll today. I'm going to add a new database, and then I'm going to add a function which retrieves items from a category. And then I've noticed that this ends with function is not really efficient, so maybe I can optimize it a little bit. Okay, so this is good, and since this is a real change, I'm going to create a branch for it. And I'm going to create a pull request. So now you notice that some checks have kicked in automatically. Let's just go into another repo where this pull request already run. You will notice that some of the checks have actually failed. So let's go browse into what actually happened. So you will notice that we have 3 checks that actually failed on CodeQL. Okay? And let's see more details for some of them. So I've identified that this query is actually not secure. So I'm taking user input and I am not sanitizing it for special characters. So this could actually be grounds for SQL injection, which is a particularly problematic software vulnerability. And if I didn't know what this was, I could do show more and read the documentation, recommendation, more information about the software vulnerability. right? So I could do all that, and in addition to vulnerabilities, it can actually also identify some common bugs. So my fix that I introduced actually creates a problem here. So we can see that we're not checking for the indexes properly, and so we need to explicitly handle a -1 case. Okay, so CodeQL actually is, like everything at GitHub, is community powered. So we're actually taking these software vulnerability checks from the security researchers, and we have identified more CVEs than any other static code application analysis. And we're used by top software development organizations on the planet. I actually have introduced a new acronym, which is a CVE. So it stands for Common Vulnerabilities and Exposures, and it's a way to reference a common known information security vulnerability. And there's another acronym that is a CNA, and it's a CVE numbering authority. And it actually stands for an organization that can assign CVE IDs to new vulnerabilities. And then another important notion is 0 day. So 0 day is a vulnerability that becomes known to good actors and bad actors at the same time. And then 0 day exploit is when hackers use that reported vulnerability to hack into software. So this is something that we don't want to happen. What we want is for the good actors to have some time before the vulnerability is reported publicly so that they can remediate the applications so the hackers could not use the 0 day attacks. So good news about this is that GitHub is now a CVE numbering authority, and so you can disclose vulnerabilities directly to GitHub, and then you can notify project maintainers. So especially for open source projects, sometimes there's no way for you to reach out to them privately, but you can do this now. So let's just show that very, very quickly. So I'm going to switch into another demo here and go into the security tab. And then I can go into view security advisories, and I would be able to view existing security advisories, and then I can create a new draft security advisory, and then I can create detailed information about that, and then you could privately discuss it with collaborators, or you could just publish it to everyone. Okay. The GitHub Advisory Database really powers the GitHub Vulnerable Dependency Alerts, but it doesn't take data just from GitHub reported CVEs. It also takes data from collaborative databases such as common community sources, white source, and so on. And so this really becomes very powerful in terms of you being able to report CVEs directly to project maintainers. And last but not least is GitHub Actions. So I mentioned it a little bit before because CodeQL is configured using Actions. But with Actions, you can really configure all of your automation workflows. So you can configure your full CI/CD as well as other workflows as we have seen. And you can host it in any language, any format. You can run it on GitHub hosted agents, which have runners for Windows, Linux, and Mac OS. And you can also run it on self-hosted runners, so any VM that you choose and configure. And it's available on GitHub Cloud, and it also is coming to GitHub Enterprise Server. And then, of course, there's GitHub Actions for Azure. So we support AKS, Azure Web Apps, and other common deployment procedures. And last month, we've seen about 250,000 unique Azure Actions being run on GitHub. And of course, Actions, like everything in GitHub, is community powered. So Actions are open source, and you're able to contribute new actions to your community, and you can also consume actions from the marketplace that were contributed by the community. Unfortunately, I don't have the time in this session to really demo on GitHub Actions in depth, but there's another session in Build on Demand led by my coworker Brian Douglas, which you can check out GitHub Actions and GitHub Actions on Azure. And I wanted to finish with this resources slide, so you might want to take a screenshot of that. So you can look at all the new features. Notice that these are short links, so it's github.co, and then check out the docs and how to sign up for beta and things like that. So with that, thank you so very much. You can find me as Divine Ops on Twitter and on GitHub. Please reach out with any questions that you have, and thank you. With this, I will hand over to Dean. So, Dean, take it over.
So thank you, Sasha, for that great presentation about what is now available in GitHub to help customers achieve DevSecOps. My name's Dean Bryan, and I'm thrilled to be with you here at Microsoft Build in this virtual medium. I'm currently a cloud security advocate here at Microsoft, and I've been doing that for a couple of years. But before that, I spent a few years in operations, I've spent some time in engineering, and I've also spent a bunch of time in cybersecurity, architecture, and InfoSec. I'm really passionate about DevSecOps and security, and I really want to talk to you about the kind of next stage of the software development lifecycle and how DevSecOps applies to that part of our lifecycle. So as Sasha stated earlier, pushing left really is important. The earlier we can remediate these issues, the way better that it is for us. Pushing left is a key component of DevSecOps. And there's a bunch of reasons for that. And one really clear one in this slide that I've replicated here from earlier on is the cost of remediation is much lower as well. But embodying DevSecOps as a whole is really about representing security across the entire software development lifecycle, from development through our deployment and also into the lifecycle of our applications while they're in production. So I want to focus a little bit more on the right-hand side of the software development lifecycle as opposed to the pushing left aspect that we may have heard earlier. The question I really want to ask is, what about as we move to the cloud? What tools and capabilities do we have at our disposal to enable us to perform DevSecOps and embody that security mindset across our entire software development lifecycle? I think that there's two things that we care about as we move to the cloud. Of course, we still care about our code, and it's really important that we protect our source code, both in its repositories and in GitHub, and also when it's running in the cloud as well. We want to make sure that our keys are encrypted in key vaults. We want to make sure that we're implementing the right identity and authorization that we need to for our applications. But we also care as well, as our applications move into the cloud, about the cloud resources and ultimately the infrastructure that our application is running on top of. This is also really, really important in DevSecOps world as well. And that's really what I want to talk about in this talk. The cloud resources that we've got running in the cloud that our applications sit on top of. How can we ensure that we're using the right tools and capabilities provided for us from Azure in order to make sure that our applications remain secure throughout their entire lifecycle? So here is the DevSecOps solutions architecture that I've taken from the docs.microsoft.com site. This is basically demonstrating what we like to call the DevSecOps happy path. What that basically means is that you have got the minimum requirements really needed to say that you're really performing DevSecOps on your development lifecycle. So through the GitHub stuff that you see on the left there, which Sasha spoke about, through to Azure pipelines, container registry, maybe our Kubernetes clusters running in the cloud. We're using infrastructure as code, key vaults for our secrets, and we're monitoring our application as well as some identity at the bottom there around enabling our users to access and securely access our applications as well. So the one part of this that I really want to focus on in this section of the talk is the right-hand side there. You can see here that I'm using Azure pipelines. Azure pipelines I'm using to deploy an Azure Kubernetes cluster as well as an Azure Container Registry instance. I'm doing that using Terraform or infrastructure as code, which we'll talk about just shortly. I'm using a key vault to secure my keys and my secrets, and I'm also monitoring that application in Azure Monitor. I'm using Azure Policy to ensure governance of my environment. And we're going to look at some demos around how you can use Azure Policy as part of DevSecOps to make sure that your applications are governed and are compliant to the requirements that you need to set. So there's a bunch of things going on here. One thing that I really want to highlight as a key component of DevSecOps is infrastructure as code. Now, infrastructure as code by definition from the docs.microsoft.com site is that infrastructure as code is the management of infrastructure, networks, virtual machines, load balancers, and connection topology in a descriptive model using the same versioning as DevOps teams uses for their source code. And I think that's really prominent. The versioning part is really important. Now, if you've been doing DevOps and you're wondering what DevSecOps is, I think the point I really want to harbour here is that this is a key element to DevSecOps. Not only does it give us repeatability and version control, which are great benefits, but it also makes our systems safer and more secure. It means we can deploy our systems safer. We can unit test them. We can check for compliance checks and vulnerabilities or secrets stored within those, right within GitHub, right at the beginning of our software development lifecycle, as well as part of our pipeline. So infrastructure as code is a key component to DevSecOps, in my opinion. There are a couple of tools that we can use to achieve infrastructure as code. We've got Azure Resource Manager, or templates, which is a declarative JSON representation of your architecture, which is native to Azure. And there are also open source offerings, such as Terraform, which is particularly what we're going to be showing here in this session today. So I don't want to bore you with slides during this whole session. What I really want to do is dive into some demos and show you how you can implement some of these controls across your software development lifecycle. And we'll look at Azure pipelines and policy and container registry and monitoring and see how we can implement these and how we can utilize these to perform DevSecOps in our own environments as well. So let's dive into the demo and see what we can do. So here I am in the Azure portal. And the first thing that I want to show you is Azure Policy and how we can ensure that our systems are compliant to any governance controls that we want to set. This is really important to enable us to make sure that we're secure. But what I really want to talk to you about is that from a DevSecOps angle and how we do continuous governance. Now, Azure Policy enables us to do that, but we can actually take it one step earlier and do this as part of our release cycles within Azure DevOps. So I'm going to show you exactly how you can do that. So here in the Azure portal, I'm going to navigate over to Azure Policy. Within here, we can see a number of options on the left here. First thing I want to focus on is definitions. A policy definition is a JSON document that defines what a policy does. Let's look at one and see what it looks like. I want to particularly look at one for Azure Container Registry because that's what we're going to be using in this demo. So we have this one here, it says preview, container registries should not allow unrestricted network access. So let's look at what this policy looks like. Here is the JSON representation. You can see that we have a display name, a policy type. You see this is built in. We won't have time to go in that today, but you can also build custom policies in here as well. And basically any attribute that you may be able to set within a resource manager or Terraform template, you can basically have a policy check that the value of that parameter meets the requirements that you need. There's a brief description here, but ultimately what we really care about is the effect parameters here. So you see that we can either have audit or disabled here in terms of what we want to do as an effect. So the user can choose what action they want to take based on this rule being triggered. But then within the rule is the really interesting bit. So we're going to say if all of the field Microsoft.container registry registries, if any of the fields called network rule set default action equals allow, this means that the network rule set is allowing access from anywhere on the internet. We want to take the effect that we've set, so we might want to audit and set an alert or something like that. That's generally the crux of this policy. Now, what we can do here is we can assign this policy to a particular scope. We can assign this to our entire subscription. We can assign this to a resource group. We can assign this to a management group as well within Azure. You can see here that I already have an assignment for this particular one to my subscription that I'm using here for this demo that I've previously assigned. In order to assign, you just click the button here and you can assign a policy. Now, where this becomes really interesting is where I can use this within my DevOps pipelines. So I'm going to move away from the Azure portal now and head over to Azure DevOps. And in this project here, I've got some pipelines set up. I've got a pipeline here for building my Docker container and putting it into Azure Container Registry. And I've got another pipeline here for building my AKS infrastructure, my Azure Kubernetes Service and my ACR container with Terraform. And then I have a release pipeline that releases that out into Azure and actually goes ahead and deploys it. If we go and have a look at this particular release, you can see in here that it's pretty straightforward. It takes an artifact from my build, which is the output from my plan for my Terraform, and then it goes ahead and deploys and applies that Terraform. So it goes and creates those resources in my Azure account. You can see that it installs Terraform and then it goes ahead and runs validate and apply here using that artifact. Very, very straightforward, simple plan. But this isn't really the interesting bit. The interesting bit here is that I can apply a policy, my Azure policy, as a release gate. Before this pipeline even triggers, I can have a gate that says, do not run this release pipeline unless this condition is met or is true. To do that, I can simply just click onto my pre-deployment conditions here. And I can go along here and I can do a gate. See, this is enabled here. And the gate that I can select here when I click add is check Azure Policy compliance. So here I can actually check that what I'm about to do within these next steps is compliant with my Azure Policy that I've set. So if I click on that, I can check my Azure subscription that I'm using. I can check the particular resource group if I want to, and a particular resource name if I want to get that granular with my policy. But ultimately here, that's as simple as it is to have my Azure Policy validate against my pipeline as a release gate. I can set some extra evaluation options here around how many times and how often I want to retry this gate to see if anything has particularly changed. But ultimately here, what we've got is the ability to validate our releases against an Azure policy to ensure governance within our environment, which is a really nice feature. Just for complete clarity, if I head over to my Visual Studio Code instance here where I'm writing my Terraform, you can see here that the default action for the network rule set within my Terraform template is to set to allow. So this gate would actually foul based on that requirement not being met. And if I then set this to deny, my gate would then be approved and then the architecture or the infrastructure would then be released and the release would happen and Terraform would apply the changes or deploy those Kubernetes resources to my account. Now, if we head back to the Azure portal, we mentioned that we were using another pipeline to take our containers from Azure Container Registry and deploy those into Azure Kubernetes Service. Now, what's a really neat thing is that Azure Security Center now has the ability to scan containers within the Azure Container Registry using the Qualys scanner. So let's have a look at how that works. So here in Azure Security Center, I can look at my recommendations for compute and apps. This is where containers comes under here. And if I select containers, I can select the resource type of container registry. Make sure that I'm filtering on the right subscription here. I don't have any sitting in that one. And you can see here that there's a whole number of containers here sitting within container registries that are not compliant. They've got 1 out of 1 recommendations here. If I was to dive into one of these here, you can see that it has performed a Qualys scan. It tells you that the vulnerabilities in Azure Container Registry should be remediated, and this is powered by Qualys. If I click into that here, you can see that the findings, the particular findings that were found, there was a user with a blank password, and there was hard-coded credentials within the Docker image as well. Qualys is able to identify these things. These are things that we should be enabling. You can enable this in the standard tier of Azure Security Center, and you're charged per scan. Normally within 10 minutes of uploading an Azure container to the container registry, you can have a report here. You can set up Azure Security Center to let you know if your container images in your container registry have known vulnerabilities, and that's exactly what we should do. So then we know that when we deploy those instances into Azure, into our Kubernetes environments or to Azure container instances, that we know that they've been scanned by Qualys and they are secure. Just something to keep on top of, and a really nice feature to automatically scan all of the containers that enter our registry. Now, the last thing I really want to look at is, once we've got our application running, how do we make sure that we're monitoring our application and we know what's going on? Now, from a security perspective, and we're definitely moving more into the kind of SecOps space here when we talk about this, Azure Monitor is the ability to help us understand our logs and understand the current state or past state of our infrastructure and our resources in Azure. So I can go in here to my log analytics workspace. This is basically all of the logs from my Kubernetes cluster, my entire Azure environment. I can pump into a log analytics workspace, and I can start to perform rich, deep queries on that log data. I can start to look for anomalies or things that maybe look out of the ordinary. To show you a really simple example here, I can just type kube events, and this will just get me a list, and I can just run that as it is. And that would get me a list back of all of the Kubernetes events within my environment within the last 24 hours. This is showing here. I can dive into these. I can look at particular types of logs. Now, realistically, if you want to perform true threat hunting or anomaly detection across your environment, you should be using a SIEM solution, and Azure has an offering there called Azure Sentinel, which unfortunately we can't cover in this talk, but I do encourage you to go and check it out if you're interested in that more SecOps space. But even as a minimum requirement, if you pump all of the logs from your Azure services into a log analytics workspace, including your Kubernetes logs, your container logs, and maybe any custom logs that you want, you can start to build metrics off the top of that, as well as start diving into your data and understanding anomalies and be able to form security operations on your environment when any issues should occur, or proactively if you're into threat hunting. So we weren't able to cover all of them, but if we look back at the DevSecOps solutions architecture here from docs.microsoft.com, you can start to see how we've implemented DevSecOps, or a security mindset, into various parts across our development lifecycle, all the way through from our creation of our code and storing that in source repository, all the way through to monitoring application with Azure Monitor. Now, there are tools that we didn't get to mention in this talk. There are also more tools in this that you could potentially use, and we saw some of those or mentioned some of those, such as Azure Security Center and Azure Sentinel. So I really encourage you to go along to aka.ms/DevSecOps build, and that will take you to the documentation that supports this solutions architecture for DevSecOps. You can read through all of the steps highlighted in that diagram there and really get a feel for how you could start to implement all of these components for the happy path and implement DevSecOps within your own application environments. Thank you very much for tuning in.